Okay, welcome back. So in first two sections, we'll talk about what is performance engineering, and we'll talk about the most important part of performance engineering, that is performance testing or load testing. In this section, we'll talk about the profiling, which is another important part of software performance engineering. Okay, so let's first look at the definition of performance of profiling. Okay. All right, what is profiling? It's a form of dynamic program analysis. So using profiling, we measure the complexity of the program in terms of space or time, or the frequency and duration of function calls. So in one word, using profiling, we want to understand, like for example, how much time and resource a certain piece of the code consumes. For example, this sorting algorithm consumes 10% of the CPU time, consumes 20% of memory usage, right? In this way, you can understand how the specific parts of your program behave, right? So then, based on this information, you can optimize your source code. For example, this part is using too much time, so I improve it to reduce this part. Or this part is used by a lot of usage cases. Every user will trigger this part. So it is very important to improve the performance, improve the speed of this part. Some other part maybe never used by users. You don't need to care about the performance of that part. Okay, that is the basic idea of profiling, right? So the objective is optimization of a program and to manage the resources. It helps to understand the behavior of a program, and also helps to evaluate and compare performance of different architectures. There are two ways to do profiling. One is to do instrumentation, another way is to do sampling. Okay. First, what is instrumentation? Instrumentation, it is to add code in the monitor program, to add external code, to add extra code to the monitor program, right? It's an internal way to measure the system. It can provide detailed data about the performance of the program, right? We can add the instrumentation or props at several levels of the system. First one, source code level, can manually automatically add more code to the source code, or we can add a binary code. We can instrument the binary code, right? We can use a compiler to automatically instrument code when compiler do code optimization, right? So anyway, we add more computing instructions into the program, right? Either into the source code or binary code, right? Motivation for profiling, right? We can connect exactly the data needed and infer the locality of the data. So whatever data we want to connect, we just add instrumentation there. So for example, you want to measure how long a method invocation takes, you just add one instruction before the method invocation and one after the method invocation. You calculate the time difference, then you know how long it takes, right? So that is about the instrumentation. So how we design our instrumentation, right? We want to identify the events to be measured. For example, you want to measure the length, the runtime of that function call. You just this is our event. You just want to identify the events, right? Choose a level of granularity. You can instrument everywhere, but the cost is very high because you add extra instruction to the source code. So the program can be very slow. Or you can enable some instrumentation while disable others, so you can have a balance between the cost and also the detailed information. So you can dynamically select the data to be saved at runtime. For example, at a certain part you want to, so when you are profiling the program, at a certain time you want to reduce granularity, you want less information, but with a lower cost, you can disable some instrumentation, right? However, there are some pitfalls of instrumentation. We need to be careful. The one is overhead. When we instrument things, we add extra instructions. The program can be very slow. It's overhead. Second one is false positives, right? Sometimes we add extra code, but actually this extra code can have a significant, the speed of this extra code is comparable to actually monitor the program. So sometimes the disturbance may be very high. It's high enough to cause false positives. You think your program is slower, but actually it's not slower. It is because your extra instruction code, right? Third pitfall is called hidden bugs. What's a hidden bugs? So hidden bugs is a bug. Hidden bugs are the bugs that you only identify them when you monitor them, but when you don't monitor them, they disappear. So hidden bugs are caused by the observer effect. If you don't observe it, it disappears. Okay. This is about instrumentation, right? We add extra instruction. It's an internal measurement. Second type is sampling. What is sampling? We don't add extra instructions to the program. So sampling doesn't affect the execution of the program, right? How it works, the operating system will suspend the CPU at regular intervals, like every second, the operating system will suspend the CPU and record the instruction that is currently executing. For example, we record this for 100,000 times, right? Then we do a statistic analysis. We count the distribution of the instructions. We find one instruction is most executed instruction. So we need to pay more attention to this instruction, right? The profiler will return the frequency of execution of the code points, as we mentioned. We should repeat our profiling several times to obtain statistical significance. Why? Because we're doing sampling. Sampling, which means you don't measure everything, you sample it. It's the same as we sample as a certain population in another population. We need to repeat it multiple times because you may miss things when you are sampling a smaller population, right? What's the difference between sampling and instrumentation, right? I would say instrumentation, you add extra instructions to a source code. Sampling, you don't add extra instructions. So sampling is less precise, right? Because you may miss something if you don't sample it, but more efficient because you don't sample everything, faster because you don't add extra instructions, it's faster, right? Sampling just captures a snapshot of the CPU. For example, for every second at certain intervals, we capture a snapshot of the CPU. Or you can think about memory, other stuff, right? So this is a sampling. If the profile operation is too short, the sampling will not capture it. It's too short because you capture every second. If the operation is less than 1 second, you may not capture it, right? So, do we do profiling manually? Yes, you can, but it is very slow and effort consuming, right? So fortunately, we have automated tools to help us perform profiling, right? The profiling tools allow you to calculate a large number of measurements and produce detailed reports. But you should be careful because a lot of cases, profiling methods are very intrusive which means they add extra overhead to the system. They make the system very slow, right? Some famous tools include JProfiler, which is mentioned, a Visual VM. There are many other tools. If you do a Google search, performance profilers, you have a lot of them, okay? I'll just show one example of how we can use JProfiler to profile CPU usage of a program, right? So basically this JProfiler would program your choosing code of the system, and it will produce a report like this one. In this report, the first column is a method for which each method, it will show like average time to execute the method, how many times this method has been executed, other information. Right? You can also show a distribution of this, such a method execution, right? Okay, profiling versus performance testing. So why we need both? We need both profiling and performance testing. Why performance testing itself is not enough, right? Why profiling itself is not enough? Why we need both of them, right? First of all, profiling, you cannot, it's hard to scale. You cannot get very detailed information while still handle a large number of users, right? Performance testing, you test the whole system, but you don't know the details. So you need profiling to know the details. There are two usage patterns. First, you do profiling, then you do performance testing. First, you use the profiling to understand the behavior of your program and identify the use of resources. After that, you can define the thresholds and objectives for the performance and testing. First, you do profiling to understand how the system works, then you define your thresholds, then to conduct performance tests. Okay. Second way is first you run performance testing, then you run profiling. In your performance testing, you will indicate the presence of performance issues. You find performance issues, you find the system very slow, but why it is slow? You don't know which part caused the bottleneck, right? So then you want to do profiling to understand which part caused the problem, to find the root cause of the performance issue. And then you can improve your code to fix it, or optimize your code to fix it. Okay, that is about profiling, and that is the lecture, the things we want to cover in today's topic. There's some exercises, so I want you to after discuss, okay? The first exercise, so I want you to use JMeter to perform performance testing. This is also needed in your TP2 assignment, okay? There's a tutorial, just follow this tutorial to load test a demo website, okay? Demo website can be the blazedemo.com, or you can use other demo websites or applications, or even a software running on your local machine, right? Tutorial on how to use JMeter, very detailed tutorial. Okay, the second exercise, I want you to use JProfiler to run sampling and instrumentation on a software running in your local environment, right? You can follow the tutorial. The tutorial tells you how to use JProfiler to do profiling and specifically instrumentation and sampling on a IDE, right? You can choose another IDE, or you can choose another application to do the profiling, okay? So this is also required in your assignment TP2, okay? Last exercise is, sorry.
In this screencast, I'm going to discuss the most important profiling.
I don't want to play this one. The last exercise is I want you to design a realistic load for performance testing. We talk about how to design performance load cases for performance testing, right? So here we want to do a small exercise. So here in a field, we have a list of sample logs. So based on these logs, I want you to design a use case model using the Markov chain. Basically, you want to, based on the logs, you want to draw a Markov chain, which it will shows what is the start action and what is the second action, and after each action, what is the probability of another action following this current action, right? You can check the details on the slide. Okay. So this other exercises also we have assignment TP2 available. Okay, it's due on October 26th. Basically, in this assignment, I want you to consider this assignment will add the performance efficiency into your quality assurance plan. Okay, so first I want to update your quality plan to consider performance efficiency factor. Second, I want you to use JProfiler to profile your version of OpenMRs. What is your version? It's the 2-feature version of OpenMRs, right? Also, third, I want you to use JMeter to run performance testing for your version of OpenMRs. And fourth, I want to monitor and scale your OpenMR system using Docker container. The detailed requirements are on Moodle, and there's also a layout or a structure of the required report. Okay, I check detailed requirements on Moodle, and also there's it's called assignment 2 or TP2. Right? Check that one. Okay, that's it. And so we only have a few students left, I think. Do you have any questions? Oh, okay.
Sorry.
Yeah.
I have one question. I want to know, this week we have a TP lab session.